Hello, my name is Christopher Clemens. I'm a full stack software developer, and today I'm going to be going over an example of enterprise or more. I mean, it's a subjective term, right? Everybody has their way of writing code and way of doing things. But from my personal experience and working in numerous enterprise applications, both in startups and large companies. One of the companies I worked in has a revenue of $500 million a year. So these are typical patterns that I see across every application that I've worked in. Now there are differences, of course, right? Right now, this is an example of a flight caching service. So basically, it just caches flights that are frequently accessed by a user. This is not from a real application. This is just some example of what you would see in a production level application. So the number one thing that I notice when I look at code that is production ready is the clean separation of concerns with distinct service layers. So I love to write code in a way where it's loosely coupled, meaning that there's not too many hard dependencies or tight dependencies within one another. So, for example, notice how I separated the ITA codes and IAT. I'm sorry, I think I'm pronouncing that wrong. I'm just gonna I'm just gonna use this ICAO codes and this, right? So I have the airports, ICAO codes, IATA codes separate. There's an interface for airport and there's an interface for flight. So as you can see, so there's different the separation. So if there's one, if we wanted to add more information about the airport, like maybe we can add information about the air traffic control tower, the manager, maybe the number of gates, maybe the airport runway like limbs, maybe the landing fees, maybe the GPS coordinates. So there's a lot of things that can go into this airport interface, right? So if we hard coded that into the flight, or if we didn't have a very strict or separation of concerns, this would get messy very quickly. And the flights will have too much, the airport information will be too dependent on the flight, right? So if we didn't have a class for airport, we was just hard coding it in. There's no really way to really track the airport that is coming from, and it can also make data messy and inconsistent later on. So that's something to bring out. There's also a dependency injection that I want to point out here, and I'll show you where that's at. So if you look at the flight cache service, I just want to find out um, where I came and used it. So as you can see, I created a service and then I'm importing a cache. So this cache is separate from the flight cache service. Even though the flight cache service is the same, really, it's the same thing as the in-memory cache service or the cache. Yeah, here's the interface for cache, and then there's an in-memory cache that extends or that implements these key value pairs, which is available in all caches. But because this one's an in-memory cache, we have certain properties and methods that's specific to in-memory caching, right? So we might be using, for example, the store that we're using for in-memory cache is the new map, right? So that's in-memory store means that it's not persistent, but there might be other cases where we may use a Redis cache or a browser cache, right, on the front end maybe. Now this is a back end code, but those are things that I think about, right? So if we wanted to change this from a memory cache to another cache service, we can do that easily by swapping out the cache dependency that we have here instead of hard coding the memory in memory caching logic inside the flight cache service, right? So this should be an extension. So look at this, and I know it's a bit complex, but I look at caching, or not caching, but I look at extending classes and using super classes. It's almost like building a car, right? If you build one car, you have the model, right? You have a frame, tires, you have axle size, engine displacement, right? So if you need to make another car, instead of creating another diagram, just use the same diagram, make a few changes, and then you have a whole new other car. If you look at games like Grand Theft Auto, oh, not Grand Theft Auto, that's a terrible example. Call of Duty is actually a much better example. As you notice, they're able to release games every season. Every few months, there's like a new Call of Duty title. And I believe, and I have never worked for Call of Duty, I worked on that video game, but I can assure you that the code that they written back in 2000 is probably very similar to the code today, maybe with some extensions. But because of this inheritance and because of object oriented programming, a game like Call of Duty can release many versions of itself without having to rewrite everything from scratch. So that's the same concept that I have here, is that instead of writing out the entire caching logic inside the flight cache service over and over again, right? If you have a user cache or aircraft cache or airport cache, we're going to have to write all this logic from scratch, right? That we've inherited from in memory in iCache, but instead we can just inject the caching service and then just use just refer to the cache variable and then make the calls from there. So that's how that works. And then inside the flight service, obviously we're using the flight cache to do all the business logic here. So yeah, that's it in a nutshell. I'm not going to go too deep into this. I just wanted to show you how the thoroughness of code that we would see in an enterprise application. And I believe is very important as a developer, especially if you are coming from a non-traditional background, like myself, right? I've been to college a few times, but didn't complete it. I did take some coursework, but again, I still have mostly self-taught knowledge, and I believe that's a really good thing too, because you get real-world experience, right? Colleges are really good at the theory, the teaching of theory, theoretics, algorithms, data structures, which is absolutely, imperative if you want to, code at one of the, these large companies. But then there's also another side of software engineering, which is related to understanding business goals and creating software that is secure and easy to work with. Right. If you think about people who have companies with 28, 20, 30, 40, 80 developers working on various different projects, you have to ensure that things don't get messy, because they will get messy. But if we have something structured out, it will make it much easier for you, saves you time, and then it allows you and your team to output more high quality code frequently. So that's all I wanted to talk to you about in this video. Thanks for watching. Once again, my name is Christopher Clemens. I'm a full stack engineer specializing in cloud computing, as well as building secure and bulletproof backends. Yeah, so that's it for this video. See me on my next one, and take care.